in group chat. So without taking much time, let's welcome our today's guest speaker, Yu-Hua, who will speak on how to accelerate AI innovation with Vertex Managed AI platform. So over to you, Yu-Hua.
Cool.
Guys, show your excitement. Let's have a huge
uh,
round of claps.
yeah. Thank you, everyone. I'm already sharing the screen. Should I like what should we do? Like
I'm stop. I'm stop
okay,
presenting.
okay, sure, sure. Okay, great, great. Yeah, let's just I hate keeping everyone waiting before the in the past 30 minutes, so I was just gonna get right into it. Um, But I'm Yu-Hua, I'm a custom engineer based out of SF Bay Area. I'm part of the team startup ecosystem development engineering, really geared toward helping startups and founders adopt Google Cloud in general. But this one particular one is for Vertex AI, and Vertex is essentially Google Cloud's one-stop shop for any kind of AI ML workloads. So just keep that in mind. Like this is a managed infrastructure platform, so that you can focus on training data, getting the training data, training your model, and deploying your model all in one single place without having to worry about the infrastructure. Here's sort of just what we're going to go over based on the questions that we sort of the topics that people are looking to do. Number 5 is probably where it's interesting. So, and I get that too. I myself, I joined Google way before the ChatGPT revolution, if you will, before 2023, and it was mostly just predictive AI, which is still relevant, but I'm sure everyone's more interested in generative AI. So we'll get into that in the fifth section there. But the beginning portion is more about like the general AI use cases where you could use both predictive and generative AI on Vertex and how it can help you. So let's get right into it. So the one thing I want you to take away from my session today is like if there is any AI ML workloads and you don't have any complex infrastructure or GPU driver or very esoteric or like unusual ML framework, you could actually just use Vertex AI to to build that workload, deploy your workload, build that model, deploy that model. Um, this is the one we've unified a lot of products into this single platform so that when you think of AI, what kind of product on Google Cloud can I use for training a model or using any AI workloads? Just think of Vertex AI. That's the reason we unified it so that people can quickly understand that's the product I go to because there's so many products under Google Cloud umbrella and it can get confusing. So I don't do, was just real quick, like obviously Google has been doing AI for quite some time, way before 2023. Again, it was mostly predictive AI, sort of classification, regression, sentiment analysis, entity extraction, that kind of stuff. And you know, building on those learnings, Google has the infrastructure. Uh, I can share the deck. Yeah, I can share the deck with Anisha, and then she could forward to you all. It's all, yeah, the deck doesn't have any proprietary information. Yeah. So, obviously, and by having to use AI in, planetary scale with billions of concurrent users at any given moment, there was a lot of learnings and experience and investment into the infrastructure needed to host that, right? And now it's kind of open to you, so you can use Vertex AI and leveraging that learning and that experience of the infrastructure to serve your users. And then scale and optimize based on Google's own learnings, right? So that's the sort of the beauty of using Vertex, sort of stepping on the shoulders of giants here, where Google has already distilled all the best ways to train models, the inference, host the model for inference, and then giving that to you in Google Cloud. And as I mentioned, right, these are some of the use cases for AI, which it's honestly, like everyone has their own use case. So these are just some examples, but I put this slide in there because I just want to keep that predictive side in mind, right? Because not I know most people want to do generative AI these days, but there are some times where predictive, the old school AI ML workloads still matter, still irrelevant, right? Like let's just want to extract, entities from a picture. Yes, you could prompt ChatGPT or Gemini, whatever, and say, "Hey, what's in this picture?" and they'll give it to you. But there are tried and true pre-trained models for that too. So just keep that in mind. Um, if you're not really generating content, you could look into predictive AI if you want to. So um, I'm gonna go a little fast just because there's quite a bit of slides. So like Anisha said, right? Feel free to stop me or ask any questions if needed. But sort of just why Vertex again, right? Number one is sort of leveraging that Google foundation, right? The Google's learnings from infrastructure to deploy AI workloads. And the second one is when you're training AI or training a model, right? The first step is a training data set. And I've seen this through a lot of customers where they have data all over the place in different tools and different cloud providers and so forth. That's going to get challenging when that first step of getting that data together to train the model, and you have to do all these operations and migrations to get this data in one single place. That will add up to your complexity and operations. And so what Vertex is great at is if you have your data already in Google Cloud, like GCS buckets or BigQuery, it's all natively integrated with Vertex so that you don't have to mess around with transporting data here and there. And lastly, the end-to-end ML operations, you could absolutely achieve that on Vertex. Basically, you shouldn't have to leave Vertex AI platform from getting your training data, training the model, and also deploying the model for serving. All that could be done on Vertex. And here's sort of just, a high-level overview of sort of the different components of Vertex. From starting from the left, right? If you're training your own data, like I mentioned, these data products are already fully natively integrated with Vertex. So quick, really easy to get going. You just point your sort of model training code to those products and you're good to go. If you want to start with foundational LLM models or other open source LLM models, I saw a lot of people asking for alternatives to ChatGPT, right? We have that model garden. We have tens of thousands of models from third party as well, but also from Meta, Anthropic. So JAX is not replacing TensorFlow. JAX is actually, I would say, peers of TensorFlow. However, we acknowledge that not many people use TensorFlow these days, and so JAX is a way to bridge between TensorFlow and PyTorch. Like we're trying to make it easier for people who are using PyTorch to adopt TPUs, and that's why JAX is there. So um, and then in the middle is sort of how you interact with Vertex is the same as every Google Cloud product. You have APIs, you have SDKs ready to use. And then I want to call out the prototype experiment section. Not everyone's a developer, right? Yes, Vertex AI is more geared toward developers, but not everyone's a developer. And business analysts could still use Vertex because there are the Vertex AI Studio on the left-hand panel. Once you log into the console, you'll see on the left hand, there are ways to experiment with just running quick experiments with Vertex AI models. Uh, and so like even business users can leverage like quick ideas or prompt like ImageGen or VO3. Like they don't need to set up the whole entire like the pipeline workflow. They can absolutely just go into Vertex and start using it without any coding background. The question about the auto ML, it's it's under the same umbrella, but honestly, like you probably would just call those auto ML um, the AutoML, like the APIs and the sort of that workflow, you could still just do it without Vertex. Like you still use the same SDK and APIs, but it is under the Vertex umbrella, but it was sort of like absorbed, right? If you think about it. So it's kind of still like a modular piece, if you will. Yeah, cool. Let's see. And this is sort of like the behind the scenes of Vertex, right? So as I mentioned, Vertex is a managed infrastructure platform. You still have to write your code, right? You still have to, bring your own data set. You still have to write your code. Um, hold on, let me see. Uh, XLA. XLA, I'll be honest, I think JAX is more focused than XLA just because sometimes when you have a PyTorch model and then you try to do XLA, it doesn't really work. So we try to gear people to use JAX for TPU workloads. So Vertex itself, right, isn't a product if you think about it. It's really a abstraction of the underlying infrastructure of Google Cloud. Underneath the hood of Vertex, it's still the same Google Cloud components of GCE, GKE, Cloud Run, and so forth. So looking at this slide here, the very bottom part, that is available as a standalone thing on Google Cloud. So the compute, the block storage, file storage, networking, that's all leveraging existing Google Cloud products. So technically, if you don't want to use Vertex, you could absolutely do everything yourself. But we'll get into it the very last section that that cost to like return, like the return on investment on building yourself may not be there. So you have to think carefully. But every component within Vertex is available as its own thing on Google Cloud as you go down the stack, right? And then we try to support the most common frameworks and software. Again, if you have some ML framework that's really not common, then unfortunately, you would have to do it yourself. But if you're using the common frameworks like JAX, PyTorch, you could absolutely just use Vertex. And then on the going up, the flexible consumption models, those are the same consumption models you would do with GCE, GKE, and so forth. Um, I just realized like I may be kicked out of the room at 10 because I didn't book it till 10:30. But we'll figure that out when we get there. um, and then so the flexible consumption models, they're actually there, right? Those are the same consumption models with GCE, GKE. And then we'll get into a little more on the dynamic work schedule or DWS, which is really what the way to consume GPUs these days. And I'll just real quick, like this is this kind of reiterating, right? The training aspect of Vertex, the prediction serving of Vertex, you could do all that on the same platform. And then, we abstract the infrastructure so you can use the whole that hardware without having to manage or provision it or keep it scaling. And the open frameworks and the open models, we'll get into it in the model garden. Real quick, GPU and TPUs. These are the same set of accelerators you would use on GC or GKE. Again, Vertex is not its standalone product. It's sort of leveraging all those products, abstracting the hard, annoying operations for you so that you focus on developing your models. But here's sort of a slide deck of all the GPU accelerator offerings, where they shine, where they are not for, where they're meant to be more perform and optimized for. And you can use all this in Vertex as well. And of course, GCE, GKE. And here's the consumption model. I want to real quick highlight the dynamic work schedule on the bottom because the top three in the green boxes, I think everyone who uses cloud is experienced with. On demand is when you request hardware right when you're using it. Okay. Obviously, with GPU scarcity these days, you try to do an on-demand GPU VM, you're probably not going to get it. So, and then cut reservations, kind of committing to prepaying, not prepaying, but like committing to use like a 1 year of these amount of compute resources, and you're on the hook to continue paying that for the year. So that's again for big players who have a lot of money, and that's usually how people have been grabbing GPUs, right? Startups that's flush
Schedule
with
a
cash.
call.
Yes. Oh, I heard someone. Um, so the cards are really meant for like I mean not meant for, but like that's how people have been grabbing GPU, hoarding GPUs if you think about it, because they don't know when they need to do massive training runs, so they kind of just buy a huge commit to try to hoard GPUs, which is tough for the rest of the people trying to use it. And then spot VMs is VMs that you could get, but then it could be taken away at any time. And we only give you a 30-second grace shutdown. So you can only really use that for workloads that could be disrupted with losing its underlying infrastructure, but continue to keep going through checkpointing or some kind of saving a particular step and continue later on.
Yu-Hua, can you unmute yourself?
Oh yeah. I
Yeah.
think when you mute everybody, everyone got muted. Yeah.
Uh, yeah.
So,
Sorry.
yeah, no problem, no problem. So DWS, I'll just go back real quick. DWS is we came out about 2 years ago. This is our solution to address that problem with the lack of GPU availability, right? Because of the people with money kind of are hoarding it. What do we do? So dynamic work schedulers is essentially a way for you to get GPUs without competing with those like million billion dollar startups, right? The calendar mode is similar to like a hotel reservation. If you if let's say I'm going to Paris, right? I will go to a website, I will reserve a hotel for 5 days. I go there, I use it up, and I pay for it, right? That's the same thing in calendar mode. You will place a future reservation of how many GPUs you need for how much time, and then we'll provision those resources for you at that time. For GPUs, you need about a 4 day lead time, and then for TPUs, it's about a 24-hour lead time. And calendar mode doesn't consume quota, so that's the beauty of it, right? Because right now these days, when you as a small user, if you try to do a quota increase on GPUs, you're probably going to get denied. Calendar mode doesn't consume any quota, so you could set that reservation and then get that GPU capacity when you need it in the future. Keep in mind though, unlike a hotel reservation, I could check out early. Calendar mode reservations you cannot. If you made a reservation for 5 days, you have to pay for those 5 days. Even if your training finished in 2 days, unfortunately, you have to pay for the remaining three. So something to keep in mind. FlexStar is similar to spot instances and more like, I would say, a restaurant experience where when you go to a restaurant, right? If there's a lot of customers ahead of you that have already placed their order, there's only one cook. It's gonna take a while to get your food, right? Because he has to go through he or she, the cook has to go through all the previous orders before getting to you. And that's what FlexStart is, right? When you send a request for a FlexStart GPU VM, you may or may not get it fast. You may get it fast if there's no one ahead of you. But if there's a lot of people ahead of you using GPUs, then you have to wait a while. So that waiting time is not really determined, and that's why it's called Flex Start. It's flexible in terms of starting, but it's the trade-off is that unlike calendar mode, if you start using Flex Start, you requested so it's only up to 7 days. But let's say you requested 5 days, and then you finish your training or your job in 2 days, you can release that and not have to pay for the remaining. So that's the beauty of the flex compared to calendar. So you kind of have offsets between like how much how guaranteed the resources versus like the flexibility of returning the resources early if you don't need to. And FlexStars consumes your spot VM quota, so that's something to keep in mind before you start using that to make sure you have the quota for requesting those. And here are the Vertex AI regions that's currently available and being added as we speak. We're going to try our best to bring Vertex to every region possible because we understand there's data residency requirements, processing residency requirements, and we don't want that to be a blockage from adopting any AI workload. Cool. Now we're going to get into custom training. I think this is more relevant to the custom GPTs that we were talking about. Obviously, this applies to sort of generic ML training, in terms of, data set, choosing your own model, writing your own model code, and then training it. But so when we talk about the custom GPT, that's more of like a GUI interface, if you will, a very sort of guardrail, like you put your data in, you click, and then you start training. We offer that too on Vertex AI. You can fine tune big LLM models. But I just want to highlight here, right, that some of the nuances in doing ML training, that's not like custom GPT. That's more like, developing your own model. Some of the problems you'll see is like the infrastructure management, the disparate tool sets and data sets that I talked about earlier, the cost and time of setting that up. And then Vertex is designed to address all that, right? To kind of abstract the infrastructure away from you, make the ML pipeline end-to-end quicker, more managed, easier for you. There's no managed infrastructure to manage. There's no Kubernetes to manage. You just specify the type of compute you need, and Vertex will just abstract all that for you. Yes. So the format is you generally like you just do a simple like CSV, like data label like that. That's generally what the training set composed of. So and it doesn't. I don't think there's a like a specific format you need to adhere to or specific columns. Cool. And then in terms of like sort of just I want to highlight real quick the ability to obtain GPUs and accelerators at TPUs. You want to leverage the dynamic workload scheduler, which can get you the GPU resources that you need. Otherwise, you have to compete with those billion-dollar startups, buying commitments and so forth. And then also we let you share your compute engine reservation and cuts as well. So let's say you're already locked in with some GCE, CPU, and memory cuts. You can still use that on Vertex as well to increase your savings. And in terms of the training pipeline, so this is something you won't see if you're doing the fine tuning of LLMs, like the custom GPT, because those are like a GUI interface that you click and upload data, click, you're done. This is more for the ML practitioners and developers where you set up a training pipeline. And what Vertex AI is really great at is documenting every single step of the pipeline. You get this tag that you in Vertex, and you can see all of the lineage data, like the metadata associated with the training, like what hyperparameters was used, what was the data set size, so forth, so that you could scientifically iterate the next improvement by changing just one specific variable and then seeing what works, what doesn't work, so that you can continue training your AML models. So coding in Colab is Colab's like a Jupyter notebook, right? So whereas Vertex AI is more, you will have your own IDE, for example, and then you would, write code in that IDE, and then interact with the SDKs in code, right? Versus like Colab is more like, you could just start writing Python code and then start running. So, and I think Python, Colab Jupyter notebooks only do Python, right? So if you're writing model code in some other language, then you have to use Vertex. So that answers your question. Real quick, here is the dynamic word search that we talked about. This is a new way to get GPU resources. And yeah, even H200 and B200 Blackwells are all available as well. So you could give that a try. And private service connects and a cool feature in the Vertex where if you need to talk to a GCP project that's in a totally different organization, totally different project, you could use private service connect, and that way all the data transfer and communication is done privately within Google's internal network, so that your data never leaves outside of Google network, never goes to the internet. And this really reduces the IP consumption range you have to do, and also added security in terms of not exposing your traffic to the outside. Uh, in terms of the training, this is actually going in the opposite direction of what people are asking about the custom GPT, right? So actually, developers are not complaining, but they voice feedback that the current model training on Vertex is too guardrail, it's too abstracted. Because again, no infrastructure to manage, you can't see the cluster that's created and everything. But some people want that, right? Some people want to get deep into the underlying infrastructure and possibly run things like Slurm, which you can't really do in currently. And so this is coming soon where you have more access and more control to the underlying infrastructure. You can see the cluster that's set up. You could do canary deployments, A/B testing, and it still has the same interface as the one on the left side, but it just you get more flexibility and control in the underlying infrastructure. So again, it's for developers and practitioners that want to get even deeper into optimizing their ML journey. And here's what I want to real quick. This is what's relevant to the custom GPTs that we were talking about. Currently on Vertex, you can just there's a menu on the left side. All you do, click in there. You select the foundational model you want to use, the foundational LLM model. It could be Gemini, it could be Anthropic's model. It doesn't have to be Google's own models. And then you can just input some training data. You don't need too much. You need orders of 100 or 1,000, maximum 1,000, and that's enough to train that LLM model for your specific tasks, and then to output information that's more specific to your context. For model, what do you? Yeah, so on Vertex AI, in terms of the monitoring storing of parameters, that's done within the Vertex pipeline lineage. Like it'll store the metadata associated with the pipeline training. Well, now we're gonna get into the inference, which is once you have your model, it's trained. Now you want to set it for prediction. Again, to do it yourself, you absolutely can do it yourself, but just the time consuming, the need to scale, the need to over provision to wait for some big event, and so auto scaling is always the key. And so that's why Vertex AI is here to solve that problem, where we have a service to serve your prediction at a scale. So we could scale up and down to zero as needed, or scale up to as much as possible to meet your demand. Again, that lower cost of TCO comes with the fact that um, they when you don't need to pre-provision when you don't need to pre-provision resources, you don't have GPUs waiting idle, costing you money. When you do the cloud model of scaling up and down, that's when Vertex can really help you save costs. It's tightly integrated with the rest of Google Cloud products. And then again, the built-in monitoring, observability, not just the pipeline lineage data, but also with cloud monitoring. What's a FSDP? Um, we'll take that offline. We'll take that offline. And then lastly, the serving infrastructure. Uh, fully sure. I'm not too familiar with that. Let's connect later because I'm not too familiar with this fully shared parallel. Yeah. Um, the one thing I want to highlight, and the last one I want to highlight on this slide is the optimized serving infrastructure, right? Remember, you're leveraging Google Cloud's learnings and investment in serving. And then so we have optimized serving containers, right? To really like make it more efficient, make it consume less resources. There's prefix caching built in so that you can reduce the compute sort of cost and have a lower latency in terms of serving. We'll get into that. Um, you can have various different endpoints once you deploy your model on Vertex. You have public endpoints or private endpoints if you want a privately accessible LLM model. And you can also have different ways of, there's also different configurations for like ultra low latency applications as well. And as I mentioned, right, you get the range of the same accelerators you can access in GKE, GCE. And again, that lower cost of ownership because we're scaling on demand versus you having to commit upfront to like 100 GPUs or something like that. And again, the security is something I want to mention too, right? Vertex is built on top of that Google Cloud foundational security of IAMs, VPC controls, firewall rules, everything. That's all built on top of it. So you can be assured out of the box, Vertex already has the security foundation of um of Google Cloud. So it's 10 a.m. I hope I don't know if I'm gonna get kicked out. If I get kicked out, I'll continue the call outside in some open area, but we'll just keep going here. This is the reservation that we were talked about earlier. If you have existing GCE reservations or cuts, you can leverage that in Vertex to keep saving you money. Here's the model garden that I think is also relevant to the people asking for alternatives to ChatGPT. Obviously, with Google Cloud, our flagship is the Gemini models. And but if you don't want to use them, you can absolutely use all of the third-party models that's described at the very bottom there. Maybe some models have a better modality for your use case, maybe more domain specific for your use case. So you could actually do all that within Vertex AI Model Garden, and it's very quick to deploy. It's a one-click deployment, and you're good to go. I think this is the next slide. Yep. So, right, when you want to deploy it, let's go through the model garden. You found a model you want to deploy. All you need to do is a few clicks on the GUI, and you can deploy a model for you to use as an inference endpoint. So this is something that you could rapidly test out all the different not GPT, all the different models that you're looking for. So again, the people looking for alternative to ChatGPT, you could just come here. You could, deploy one that you see in the model garden or something you saw on Hugging Face that people are talking about, and give that a try. Here I want to just highlight that performance optimization piece because I think that's just it's what's unique on Vertex AI inference. The flexibility part we just talked about, right? You could really quickly deploy in the GUI, but in terms of the optimizing performances, we have optimized containers for our own flavor of VLM and HexLM to really help you efficiently and reducing latency in terms of serving your model. Obviously, and then the bottom part, the observability I mentioned, like built in with cloud monitoring, you could quickly go through and check your model drift, check your model skew if there's anything happening there. Um, Hugging Face, again, like it's the huge repository of different models. And we actually curate from Hugging Face verified models that are trustworthy and reliable so that you can be safe, you can be comfortable in using that in your production workload. And yeah, we'll get into it right now. So our optimized VLM is a inference framework, right? That's open source. Anyone can use it. But we have optimized VLM where it's 50% faster than the open source model because again, taking that learning from it's Google's own sort of inference needs, right? So this container can really efficiently serve your model. HexLM is designed for TPUs, so that's the difference. HexLM is designed for serving inference on TPUs. And so again, and obviously this is more everything grown from Google because not you can't find TPUs anywhere else. And also, for example, some people mentioned about JAX. That's also from Google because we're really trying to get people to adopt TPUs because as you know, like the market share for NVIDIA GPUs versus TPU it's not comparable, right? So, but HexLM is like a different flavor of serving models on TPU, and again, it's also optimized heavily so that you can really serve your model quickly. We have again the preface caching I talked about, right? If your LLM keeps being prompted with the same questions or this and generating the same output, we could cache that for you so that you don't have to redo it, right? And then when the LLM doesn't have to redo it, it reduces that time to first token, it reduces your cost, and it's just good for everybody to cache as much as you can. And we do that in our serving optimized containers. And lastly, like if you don't want to use those serving containers, you have your own serving code, you have your own flavor of it, VLM, for example, you can absolutely still do that. We have pre-built containers that really just have the generic machine learning libraries and frameworks. And so the dependencies is already pre-installed, and then you just bring your own model in to start using it. So this is something for people who want something more custom. And again, the monitoring is all built in with cloud monitoring. This is the same tool for everything Google Cloud, so you don't have to relearn anything. You can just come to this dashboard and see how your model is doing, see the Vertex AI training jobs and so forth. And lastly, the IAM control policies that I talked about a little earlier, it's all still being leveraged. You could absolutely fine tune permissions on your on your LLM or your model inference endpoint so that only the people who are permission to use it can use it, right? To really make that extend that IAM security that's very common across clouds into Vertex AI. And lastly, the evaluation. Obviously, when you have a model running inference, you want to continuously monitor it to make sure it doesn't drift or skew. The automated metrics and the safety bias that I think most clouds have that. The auto side by side, the number 2 one is unique, I think, on Google Cloud. It's essentially using a LLM to be a judge. So what happens is, let's say you want to compare 2 different models, right? You could get 2 different models, the same data set, ask them for the output, and we have a third LLM automatically rating those outputs and giving a score to see who is performing better or worse. And this can really help in terms of evaluating LLMs so that you can quickly understand which LLM performs better or worse. Oh, and then if it doesn't perform well, what can you do to fine tune? Like you can then fine tune it and then try again, pitting it against the previous model. So our registry is the container registry, or artifact registry. Sorry, container registry is deprecated. Artifact registry, and then it just leverages that underneath the hood, right? So it doesn't, again, Vertex is not its own product. It's like an umbrella doing all the modular pieces of Google Cloud for you. Yeah. So now we're gonna get into generative AI section. This is great. This is the section that I think everyone's more interested, even me, right? So it's no secret, like everyone wants to incorporate Gen AI workflows into their environment or their projects, and so we're really here to help you do that and not kind of lower that barrier of entry so that you can start using the LLMs because from the theme of the questions, right? Like I think everyone is kind of bound to ChatGPT maybe because it was the first one released and sort of you locked into that interface. And we're trying to give you options, right, beyond that. Um, so just real quick in terms of the speed of improvements, this is the slide where I have to tell you upfront, maybe next week some of the slide deck that I present will be out of date. That's just the way AI is evolving, the speed of it's evolving. You know, for my personal example, less than 12 months ago, August 2024, AI models was still creating kind of garbagey videos, right? It's grainy, it doesn't realistic. And now we have VO3 where, it's almost impossible to distinguish from reality with audio, with relevant audio and relevant lip syncing to talking the script that you're asking it to, right? We went from that, from, mute videos and grainy and weird to like realistic videos with sound within less than 12 months. So that's how fast it goes. And so that's why next week, maybe some of my slide deck will be out of date. So just keep that in mind. And in terms of the problems we're hearing from from the field or from customers, yeah, VO3 is like I haven't seen any other video LLMs that can generate sound too at the same time. Most of them is still just video with no sound. So I'm curious to see who comes next because generally like when someone releases something, someone else will come release it right away. Uh, so we'll see who's the successor to VO3 here. But in terms of like the problems that we're hearing is just people are frustrated with how to get my custom LLM up and running, right? How do I make sure the RAG someone mentioned about RAG as well, right? How can I make sure my LLM outputs like correct data and not hallucinate? And so our sort of a solution on Vertex as well um, is more toward like the generative AI piece where we have the agent builder to help you build agents. Someone mentioned about AGN and workflows. You could build agents and deploy agents within Vertex, but to connect it, you still need sort of your own components and code to connect the different agents you built. And it's not listed here, but sort of the yeah, the model garden we talked about, like with all the open source models, and then the fine tuning we'll and sort of evaluation of the model we'll get into in a couple more slides. The AI computer is essentially the underlying infrastructure that we mentioned. When you use Vertex for generative AI, you don't need to worry about any of the underlying infrastructure. And like I said, here's what's available now, and you can see it's dated July 22nd. See, it's not even like July 2025, right? It's like a specific date because that's how fast AI moves. I want to call out the thinking budget that we have on Gemini. So this slide is more geared toward using Gemini models, right? You have that thinking budget, which could like you could cap how much to think for a LLM, so that could reduce your cost, right? Because you don't want someone to go out of control and prompting so much and running up a huge bill. Um, the live API that's currently available in Flash 2.5 Flash, that's designed for like a chat kind of workloads where you're streaming input output with the LLM. And then the provision throughput is something you can prepay capacity at a certain time. So let's say you have a Black Friday, Super Bowl type of event coming up for your project. You could buy pre-provisioned throughput, so you could be sure during that time your LM endpoint will not go down and be able to serve millions of requests. And then when that time is over, then you start paying for provisioned throughput. So it's not something you lock in; it's like a subscription for a specific time. The model optimizer is another cool feature, and I think ChatGPT released this. I think whenever their last announcement was, they're able to like shift between GPT-4 and 5. This is a similar concept where essentially what this is like if you're asking the LM very simple questions like what is the tallest building in the world, you don't need Gemini Pro. You don't need to pay that kind of price for a very basic question. And so our optimizer gives you one endpoint, and then it could choose between Gemini models that best fit that prompt. And that way, if a simple prompt could be done with a Flash model at a cheaper cost, we'll just automatically route to that and use that LLM to generate that response. So this really helps you in terms of cost and quality. So you can really efficiently allow your users to generate content based on the type of prompts they're using. Currently, it supports these two, the Flash and Pro, 2.0 Flash and the 2.5 Pro, and it's only text only. So then, if you send an image into the model, that will have to route to Pro. But again, this is like something that's built. It's there's nothing to configure. You just use it on Vertex AI. And the provisions throughput, as I mentioned earlier, it's not a you don't lock it in. You subscribe to a certain time frame. Like again, for a Super Bowl, Black Friday type of event, you buy the provision output. You have dedicated capacity for your LLM. So then you can be sure it will be on during those high traffic events. And in terms of the grounding and the rack, right? This line, the next one talks about that, right? One of the big problems with LLM is the hallucination, right? I still struggle with it myself. Like every time it outputs, I still have to check to make sure it's correct, and it's kind of frustrating, to be honest. Like it feels like doesn't save me time, right? So what Vertex Agent Space offers, and that's the product that I want you to take away with Agent Space is it's quickly designed for you to connect with your data sources so that when the LLM outputs something, it will cite where it got this output from, right? And that way you could be grounded in your data, knowing that it didn't say this out of the blue. Like it extracted the data from this particular data source and then output the information out to you. And of course, it's integrated with Google Search, right? Obviously, because of Google, but you could connect various data connectors, like Jira, third-party data, and so forth to ground your LLM so that it doesn't hallucinate or doesn't give you wrong information. And again, this is sort of the RAG solutions that we can offer. The very top is the agent space. Right now, you go into Vertex console, or the agent space console. You can start using agent space out of the box. It's a GUI interface to connect the different data sets that you have. You could put that on let's say you put your own data set on a GCS bucket. You could just click a few clicks and you connect to that data set. And the agent space is going to start ingesting and creating vector embeddings for that all behind the scenes. And once it's done, it'll tell you it's ready to be served as a RAG endpoint data store. And then you can just start when you start prompting it, it'll start referencing those particular data. So that's out of the box solution. And going down to the bottom, right? Suppose you have a very specific RAG solution or RAG workflow that doesn't work in agent space. You can actually still build that within not just you would probably need different components of Google Cloud, but Vertex could help you in terms of hosting that LLM, and then you could potentially use other methods to pipe the data into the LLM, or some other way of training the LLM programmatically, and so forth. So you could do it DIY if you want to, but the agent space at the very top is out of the box, no developer experience needed. And the agent builder I like to think of it as like a scaffolding for building agents. So the animation that you're seeing here, right? Let's say you write your agent code, right? You write the sort of everything you need to write in there. The ADK, the Agent Development Toolkit, allows you to quickly create and here we go. This is going to do it. It's going to run the ADK, and here, it's going to create a sort of a scaffolding environment where you can start prompting the agent right away. And then on the side, it doesn't show here, but on the side, you can adjust temperature, you can adjust different configurations, and you can also see sort of workflow of how the agent's responding. So this is, again, it's geared toward people who are developers that's writing agents, and the ADK helps you get going faster by quickly testing against the agent as you're developing it, right? Agent Engine is where you can deploy the agent on Vertex. It deploy as an endpoint to start serving. And then Agent Garden is sort of like a repository, like kind of like a artifact registry, Docker registry kind of thing, where you can have a repository of the agents that you've built. This kind of just highlights overall what you can do with Agent Builder. So the person mentioning about the AGI framework, you could build the agents within Vertex with Agent Builder quickly, and then to hook them up, you probably need like a GCE or GKE cluster to kind of be like the glue, right? The glue connecting the different agents. But the ADK really helps you, like I said, as you're developing the agent, you can prompt against it, so you could iterate really fast. And when you're testing on Vertex AI Studio, the again so AI Studio is where any user, right, of AI doesn't have to be a developer. You could be someone with no coding knowledge, and then you can go in there, you can start prompting against the LLMs and testing things. Uh, we have the prompt assist, which helps you write better prompts. As you know, LLMs really shine if you give it a very specific and precise prompt. And so you could use the prompt assist to help you do that, to kind of just describe your idea and then use prompt assist to generate a better, more detailed prompt. And then the evaluation services is the auto side by side I was talking about earlier, right? You can analyze the outputs of different LLMs, or using the auto side by side for the automatic judge to see which LLM is performing to your expectations, so you can be sure to improve or release it for production. And now this is another cool, yeah. So the custom agents you build, that will be in the agent the agent sorry, the agent garden. um well, I mean, after you train the LLM with your own data, then you can use that in auto side by side. Yeah. So the prompt optimizer is something I think also unique on Vertex, and this is geared toward optimizing that system prompt, right? So in the beginning of your LM model, you typically write things like, "You are a medical doctor with 10 years of experience in brain surgery," something like that, right? And then you basically give it some context so that the outputs of the LM adheres to that context. However, that system instruction is also crucial in the outputs later on, right? So the prompt optimizer here is designed to uh, refine that system prompt. So you have two ways to do it. Number one way is you use the SDK. You tell the prompt optimizer, "Hey, here's my system instruction. Can you help me refine and optimize it?" And it'll just spit it out based on Google's own sort of data sets. The other way is you supply your own data set. You could supply prompts and the outputs that you desire, right? As a training data set, and then give it to the prompt optimizer. And the prompt optimizer will ingest that and then give you the best tailored system instruction for your LLM for that use case. So this really helps you, because a lot of focus has been on the prompt assist that we talked about earlier, where you want to optimize the prompts that you give to the LM as you're interacting with it. This is the one product where, even before that part, right, you want to optimize the LM to have a good context of what you want to do. And so the prompt optimizer does that. And it just became GA, I think, 2 days ago. See, as I mentioned, like how fast things go. This just became GA 2 days ago. So, and lastly, in terms of the supervised fine tuning, again, like this is the custom GPT we're talking about, right? Right now, you log into Vertex AI, you could select fine tuning. You select, for example, a Gemini model, and then you fine tune. You could supply your own training data set to fine tune the Gemini model. So pretty straightforward. It should be similar to the ChatGPT experience. I understand the ChatGPT experience is probably even more geared towards non-developers, but I would recommend give Vertex a try, because not everything needs to be written in code, right? So, and cool. Good into the last section, and we're really great on time, and I didn't get kicked out. This is something went right today, so I'm feeling good. In terms of the TCO analysis, I think you know what people get hang up on is sort of like my infrastructure costs, right? Like how much I'm paying to the cloud provider, how much I'm paying to a particular vendor. But that's not always the actual the cost of doing things, right? You need to take into account, yeah, no problem. You need to take into account the sort of that cost of people and the cost of people doing unnecessary operations, right? So at the very top, right, when you see that savings number, right, that's not a pure savings number from just computing GPUs or just paying a vendor, right? Because that's impossible, because GPU prices are pretty standardized. There's no If there's a place that you're paying like 3 times more price for the same NVIDIA H100, no one's gonna go there, right? So the savings isn't necessarily like the hardware infrastructure savings. It's more about utilization and the people that you have to hire, right? So I mentioned earlier those billion-dollar startups, they hoard GPUs, right? I've seen that. I've seen that. They just immediately come to us and they're, hey, we want to commit to like 200 H200 chips, and yeah. So then they hoard all these chips, but then they don't train all the time. And when they don't train all the time, that compute instance is idle, and that's costing them money in terms of opportunity because technically they could have used that money somewhere else, but they are locked in on these idle GPU instances. So that's the number one savings you get with Vertex. And number two is actually the less amount of people you need in terms of operations and support, right? Without having to manage infrastructure, you don't need to hire 15 full-time employees and with five of them managing your Kubernetes cluster, right? You could have a skeleton crew and just leverage the Vertex abstraction in terms of the underlying infrastructure so that your team can just focus on writing code, preparing data sets, fine-tuning models, and giving your end users a better experience versus having to manage the underlying infrastructure that your end users never see. Yes, I'll absolutely forward it to Nisha. Um, so that's all I want you to take away with, right? Like the savings isn't always just the pure compute resources. It's always you have to take in the utilization and also the people you have to hire. And again, this is the return on investment, right? Like if you prepaid a whole bunch of GPUs, like your return on investment is gonna dwindle as you go, just because you have all that spent upfront. So capex, right? And this is the last slide, I think. That's the last slide. This is the second to last slide. This is mainly talking about sort of the regions that we're going to. I mentioned earlier, right? Because they're very sensitive. People have or governments have very sensitive data residency and processing residency requirements. So we want to be in every region so that governments or even like sort of Department of Defense or other countries like sensitive stuff. They want to keep in their locality, and we're trying to do that for everybody. So we don't want that to be a sort of bottleneck or obstacle in adopting AI in general, not just Vertex. And then lastly, sort of just summarizing the Vertex AI difference, right? Again, I want you to take away with is it's a umbrella to abstract away from any underlying infrastructure. Um, so on AWS, I know it's more equivalent to SageMaker. On Azure, I'm not too I don't know of the product name. I'm sorry, but AWS is equivalent to SageMaker. That's the closest one, but it's not really exactly the same. Yes, please go ahead. Oh, okay. So the one thing take away is Vertex is a umbrella of Google Cloud products. Underneath is all the same Google Cloud modular products, but it abstracts a lot of the operation and infrastructure for you, so you can focus on writing, getting training data sets, developing your model, and serving your model. That's it, right? That's the difference. And again, you're leveraging on decades of investment from Google itself, serving billions of users concurrently, and you can leverage that in Vertex out of the box, and knowing that it's been optimized for billions of users. And that's it. I was told to leave this slide for the last one, but yeah, like I said, thanks so much everyone for hanging out with us. Apologize for the beginning in terms of the technical difficulties, and I'm so glad I didn't get kicked out. For those of you who don't know, Google's offices, the meeting rooms are very tough to get, and typically you get kicked out right as your time is up. So I'm glad it all worked out. So thanks to everybody.
Thank you, Yu-Hua, for your wonderful session. I hope everybody has enjoyed it. Guys, how did you find it? Show your
Amazing,
excitement.
amazing. Thank you so much,
Amazing.
Yu-Hua. I love everything that you shared this morning. We learned a lot.
Well, thank you, and yeah, like I said, I'll share the slide deck with Nisha, and then feel free to get it from her, and then you could check these out on your own time. Yeah.
Yes. Thank you so much, Yu-Hua, for your wonderful session and your precious time. And everyone, I would like you all to please scan this QR code and fill the survey and share us. How did you find this session? Any improvement you would like to tell and suggest so that we can implement it in our upcoming sessions? And you just keep on giving us, showing us emojis just to show that yes, you found it good and interesting and insightful. Amazing. And do fill the survey and tell us how did you find it. Do we have any more questions?
Thank you, everyone. Thank you.
All right.
Thank you for a
You can connect
wonderful
with us.
session.
Yes.
The UF Core of Hudson Jr. car dealer, Lamborghini Bugatti, Brabus.
Thank you, Alfred. This is totally not the platform for that, but have a great rest of your day.
Have a wonderful day.
You can connect with us on LinkedIn. We keep on sharing updates about our upcoming events. So you can connect with speaker as well if you have more questions, more doubts, or you want any more information from him. So you can connect with him on LinkedIn. I have shared all the links over the chat. Let me share it again.
Cool. Yes. So again, thanks everybody for joining. I hope you'll continue with the AI journey and develop cool products that we'll hear about, right?
Thank
Okay.
you again.
All right.
Have a
Okay.
great
Thank you,
day,
everyone.
everyone.
Bye bye.